Hello, welcome to another very interesting episode in which we are doing kind of experiment in this Stratify channel. Because in this episode we will be not talking about a particular topic. We will be talking about questions which are related to particular topic. So first of all, let's talk about little bit previous episode. So we have talked about dark matter. In that episode, we have deeply understood it and we told you that how you can actually detect it and what are the current theories which are just roaming around researchers and scientists. In this episode, we'll be talking about some frequently asked questions related to dark matter. So first of all, if you love this kind of things, this kind of episodes on our channel, then you can comment us on YouTube. Also, if you want a separate podcast series on this question and answer thing, then we can do that also. We will make a separate podcast series in which we will be discussing about only questions and we will try to provide a logical answer on that particular question. Okay, so continue our episode. First question which many people ask about this dark matter is that can we actually detect dark matter? So in previous episode we have told you already that we can detect dark matter using gravity. But is there any other techniques? So first of all, if dark matter is made from WIMPs, so by the way, WIMPs full form is weakly interactive massive particles. So if dark matter is WIMPs, then they should be all around us, invisible and barely detectable. So why haven't we found any yet? While they would not interact with ordinary matter very much, there is always some slight chance that a dark matter particle could hit a normal particle like a proton or electron as it travels through space. So researchers have built experiment after experiment to study huge number of ordinary particles deep underground, where they are shielded from interfering radiation that could mimic a dark matter particle collision. So what's the problem? After decades of searching this particular thing and researching this particular topic, not even one of them detectors has made a credible discovery. Earlier this year, the Chinese Panda X experiment reported that the latest WIMP detection history shows nothing. It seems likely that dark matter particles are much smaller than WIMPs or lack of the properties that would make them easy to study, which was told by physicist Hei-Bu Yu, who is the physicist in University of California. So according to him, we have very less information about dark matter to actually study it. Next very interesting question is that what are the properties of dark matter? Astronomers discovered that dark matter can be detected by gravitational interaction with ordinary matter, suggesting that this is its main way of making its presence known in the universe. But when trying to understand true nature of dark matter, researchers have remarkably little to go on. According to some theories, dark matter particles should be their own antiparticles, meaning that two dark matter particles would annihilate with one another when they meet. The Alpha Magnetic Spectrometer experiment on the International Space Station has been searching for the strong signs of this annihilation since 2011 and has already detected hundreds of events, just like I told you about this dark matter. Scientists are still unsure about this particular dark matter, that these collisions are actually coming from dark matter first of all, or is just another cosmic event which is happening in the corner of universe. So that question will remain unsolved, but yes, there are chances that dark matter actually exist. And let's move to other question, which is, will dark matter let us travel through time? Not necessarily dark matter, but if you want to travel forward in time, then there is always way you might be able to do that. If you have seen Interstellar, then you know that what happens there. If you go to somewhere that has strong gravity, time flows differently, and so maybe a year for you is 1,000 years for someone else. And we know that dark matter is connected or related with gravity, and it's possible that we use dark matter to travel through time, but it's not necessarily. Next question is that does dark matter exist in every galaxy? It so massively overweighs than ordinary matter that dark matter is often said to be the controlling force that organizes large structures such as galaxies and galactic clusters. So it was strange when earlier this year astronomers announced that they had found a galaxy named NGC 1052 DF2 that seemed to contain hardly any dark matter at all. So dark matter is apparently not a requirement for forming a galaxy, but it can be found or it can be not found. So it's myth, and it will be myth for now at least, which was told by Peter Wen, who is a professor at Yale University, and it's written on space.com. So that's what exactly we know about dark matter in that particular question. So the next question which was asked by many people on internet is that dark matter interact with something or not? So the answer is yes, absolutely. But this is much harder than you might think. First, researchers can only study dark matter by seeing how it affects the universe around it. Up to this point, the only thing that has been observed is the gravitational effects of dark matter, which further clouds our ideas on the subject. From previous studies of the dark matter phenomenon, we do know that it impacts celestial objects. But what if dark matter is not a particle? Perhaps it is filled, or maybe we do not fully understand how gravity actually works. In 2015, researchers observed 4 large clumps of what they believed to be dark matter surrounding 4 colliding galaxies. Their observation showed one of the clumps weirdly lagging behind its galaxy. Not only did this appear to confirm that dark matter affects galaxies, but it also demonstrated that dark matter could interact with other dark matter. Yet we have to see if dark matter interacts with ordinary matter, but that's what we know. So does dark matter consist of more than one particle? The ordinary matter is made of everyday particles like protons and electrons, as well as a whole zoo of more exotic particles like neutrinos, muons and pions. So some of researchers have wondered if dark matter, which makes up 85% of the matter in universe, might also be just as complicated. So there is no good reason to assume that all the dark matter in the universe is built out of one type of particle, which was told by physicist Henry Kez of Harvard University, which is written on space.com. So dark protons could combine with dark electron to form dark atoms, producing configuration as diverse and interesting as those found in the visible world. Kez said this particular theory on space.com, and you can read about it. So this is the information from article of space.com. While such a proposal have increasingly been imagined in physics lab, figuring out a way to confirm or deny them has so far eluded scientists. So let's talk about dark forces. No, we are not talking about the dark side of the force, yet it could be work fully or similarly for all we know. As mentioned above, dark matter could be comprised of what is called dark particles. The way the dark protons and dark electrons interact with each other could explain why dark matter clumps together, forming spherical halos around galaxies, stars and planets. This could also open the possibility of the existence of dark photons. What are dark photons? You may ask. In short, they are photons exchanged between normal particles that give rise to the electromagnetic force, except they could be felt only by dark matter particles. Theories like this could open up Pandora box of a whole other side to the universe. And that's where I want to end this episode. So I think you are wondering so much things here, and if you don't know what exactly dark matter is, then you might want to check out our previous episode. So that's it for this episode, and I will meet you in another episode with another very great interesting concept from this world, from this science, from this universe, or from ancient India for sure. Thank you so much.